Hello everyone, and this is Devabrata here. So welcome to all of you to our channel Schrodinger's Cat. In our previous lecture, we had discussed the modern physics, and today we'll discuss the solids and semiconductor devices. That the first one we should cover the semiconductors, diodes, Zener diodes, LED, photodiode and solar cell, transistors and logic gate, and the total number of questions are coming in the NEET exam 2 or 3, and the JEE main 3 questions or 4, and JEE advanced 3 questions are coming in this topic. And I just confess one thing, that for your exam point of view, today we just do not discuss the theory elaborately, just cover the chapter summary in a nutshell and do problem in NEET JEE main and advanced, and after we got time we just cover the theory in elaborately. So let's get started. First of one, in the semiconductors, I just draw a line for your better clarifications. So first of one, in the semiconductors, that the density of charge, carrier and the conductivity is defined the sigma equal to J by E is equal to NE V by E, and the sigma is written as basically the NE mu, and the conductivity of a semiconductor is written that the sigma Ne electron mu E plus N whole electron mu H, where the Ne and NEH, the density of the conduction electron and the holes respectively, and the mu E and mu H be they are the mobilities. And the next one, the forbidden energy band gap is written as the Eg is equal to H nu is equal to Hc by lambda, and the intrinsic concentration Ni varies with the temperature T, that the Ni square is equal to A naught T cube exponential minus Eg by kT, and the conductivity of the semiconductor is sigma, that the 1 by rho, we just written this formula, E should be common here, Ne mu E plus Nh mu H, and conductivity of N type semiconductor, the N type, that the sigma N, that is the End mu E, and for the P type, that the sigma P would be Na, that's the acceptor, here D means the donor, and mu H, mobility of hole. Current in the junction diode, that the I equal to I naught reverse saturation current exponential EV by kT minus 1. This is the diode equation, diode current equation, and the dynamic resistance, the RD, is del V divided by del I. And the next one, that the half wave rectifier, that the peak value of the current Im, this is very important formula, peak value, we just covered in the AC circuit also, that the Rf plus RL, this is the peak value current, and the RMS, IRMS is equal to I peak value divided by 2 DC value of current, the IDC is equal to Im divided by pi, and the peak inverse voltage, that peak inverse voltage is equal to Vm, and the DC voltage VDC is equal to IDC RL, that is equal to Im by pi, just put this value Im divided by pi into RL. Next one, that the full wave rectifier. For the full wave rectifier, the peak value of current Im, that the Vm divided by Ra plus RL, and the DC current IDC is equal to 2 Im by pi. Next one, the RMS value IRMS equal to Im by root 2. Next one, the peak inverse voltage, that the peak inverse voltage is equal to 2 Vm for full wave rectifier, and the DC voltage, DC value of the voltage, that the VDC is equal to IDC into RL. Just put this value here, it would become 2 Im divided by pi into RL. Next one, that the ripple factor. So ripple factor is the R defined at that the RMS value of the component of wave divided by average or DC value is written as the root over I RMS divided by IDC whole square minus 1. And the form factor here, that the IRMS divided by IDC, IRMS by IDC. So next, that the PN junction as a rectifier. So the PN junction as a rectifier, that is a diode with resistance, and here the AC voltage. So this is V and this is diode and the resistance R. So I would become V sin omega t phase phi divided by total R plus R junction. So I would become that V naught by I sin omega t plus phi. So next one, that the junction diode and the transistors. So for the junction diode and the transistors, we just separate this board. And so first of all, that the symbol of PNP transistors, this is the PNP. We have the elaborate lecture of the transistors, the BJT, in our IIT JAM lecture series. We just go through, and here we just summarize here. This is the emitter and this is the collector, the current emitter to base. This is the PNP, and next one the NPN. So this is the collector, this is the emitter, and this is the base, and current would pass through the base to emitter, and the IE current, emitter current, would be I base plus I collector. So next one, the PNP transistor as an amplifier. So transistors as an amplifier, that we just now start here. I just discuss a figure for a better understanding, that here this is the transistors, this one with this. So this is point and here is voltage applied. So here on the next, so this one the R1, this is the R2, this is the input signal sine wave, output should also the sine wave signal, where this is emitter and the here collector current IC, this is collector and this is base, current would flow to emitter to base. This is for the PNP transistors, here this is the base current IB, and this is the emitter current IE. So here this would be VEB, and here VCB. So this is the resistance R1 and the R2. So this is the common base amplifier, that the CB mode. Here the current gain is written as the alpha defined by del IC divided by del IE, and the voltage gain AV, here alpha into R2 divided by R1, and the power gain AP would be the alpha square into R2 divided by R1. This is in the CB mode, and we just now do here the CE mode. This is very important, the C mode, that the transistors here so this is a part and this is this one. So here this is a voltage applied, and here also plus to minus. Here this is a resistance R1, and here be the R2. This is R1, R2, input signal IP, here the output signal OP, and this is base, collector, and the emitter. Current would flow from emitter to base. This is the base current, collector current, and here the emitter current. This is the VEB, and this is the VCB. So this is the PNP transistors, that in C mode the current gain beta is defined as the del IC divided by del IB, and the voltage gain here AV, that the beta into R2 divided by R1, and the power gain, that the AP power gain, that the beta square into R2 divided by R1. So last one, that the relation between the alpha and beta, that the beta equal to alpha by 1 minus alpha, or alpha equal to beta by 1 plus beta. These are the relation, and 1 minus alpha into 1 plus beta is equal to 1. 1 minus alpha and the 1 plus beta is equal to 1. Go ahead, our next topics, that the logic gates. So that the logic gate, so first of all, the Boolean algebra, the OR operation, that A or B equal to Y, that this is a symbol of OR gate. This is A, B, input and output Y, OP, and the truth table here, the input A, B, and the output Y, that the operation that Y equal to A plus A or B, that is the 0 0 0 1 1 0 1 1. So operation would become 0 1 1 1. So this is OR. Second one, the AND operation. So AND operation, that the Y, A and B, that A dot B, the circuit symbol here, this one, this is A, B and the Y. So here the truth table, A, B, Y, 0 0 0 1 1 0 1 1. So 0 0 0 0 0, this one the 1. The third one, this is the NOT gate. This defined in the circuit diagram here, this is NOT, where the A means A bar, this is the Y equal to A bar, and the truth table here, that the A and the output Y, so 0 1 1 0, this is the NOT gate. Next one, that the NAND operation, that means the Y A B bar and the gate symbol, that this is AND and this is NOT, so equivalent to this, this is the NOT, this is the NAND. So here the A B and the A B and the Y, this is the NAND, and the truth table, that the A B the A B and the Y, that the NAND operation, that 0 0 1 0 1 1 1 0 1 1 1 0, this is the NAND operation. Next one, the NOR. For the NOR case, that the Y equal to A plus B bar, that this is the OR and this is the NOT. So this is the NOR, that the AB, this is Y, is equal to A plus B bar. That the NOR gate, that the truth table, A B input and the output Y, that for the NOR operation 0 0 0 1 1 0 1 1, 0 0 means 1, 0 1 0 1 0 0 1 1 0, this is the NOR operation. And the next one is the XOR and the XNOR. So that the XOR operation means Y output, that the AB bar plus A bar B. So the gate symbol here, this one, this is the A B and the Y output, this is the XOR gate, and A B and the Y output. So the 0 0 0 1 1 0 0 0 0 0 0 0 1 1 1 0 1 1 1 0. So this is OR gate. And the exclusive circuit diagram, that so this is the AND and another one is the AND, this one is signal, another signal, and this is the NOT, and here also the NOT, this and this here, these are connect into OR gate. So this is basically in this connection, and these are the A and the B, and this connection with here. So AB here, this is the AB bar and this is the A bar B, this is the Y. So Y equal to A B bar plus A bar B, this is the operation of the XOR gate. And you just do in your homework that the XNOR, I do not here elaborately discuss, you just do in your homework, these are the same XNOR. So next one, NAND gate as the basic building block, that any logic gate can be constructed by using only the NAND gate, that not using NAND. First one, not NAND use, you have to do the NOT. So this is, you just construct this type. And NAND to AND, that this is the NAND, you just do this one. So this is the AND. So NAND to OR, so two NAND, this one, these are join into another NAND, this one, this is to NAND to OR. So you just now do in your XNOR gate that here the XOR, this is the operation of y A XOR B, and the XNOR A XNOR B. These are two operations. And so we just switch our lecture in a problem discussion session. So first problem is coming from the NEET 2016, saying that the given circuit has two ideal diodes connected as shown in the figure below. The current flowing through the resistance R1 will be what? So here that the current I would be by the Ohm law, that I equal to V by R1 plus R3. This is current flow in this direction I. This is in the forward bias. So here we consider, and this is in the reverse bias. We not consider this type, these portions. So that the voltage across 10 and 2 plus 2, so it would become 2.5 ampere. 2.5 ampere, A would be our correct answers. Next, JEE Main 2023, that the output waveform of a given logical circuit for a following input A and B shown below. This is the output waveform. So what should be in the match with the circuit? So here this is an AND, and this is Y1 and this is Y2. So this is Y is equal to Y1 Y2 bar. So you first draw a truth table here. This is A, B, Y1, Y2, and the output Y equal to Y1 Y2 bar. So first one 0 0, 1 0, 0 1, and last one 1 1. So 0 0, this one 1 1, and the multiple and the bar would be 0. This is 0 1 1 1 0 1 0 0 1. So we just now draw here the time diagram. This is the truth table and this is the time diagram, that the TD. So first one is the for time T1, and this is for T2, this is for T1, T3, T4, T5, and the T6. T1, T2, T3, T4, T5, and the T6. So first of one, that here also this is input. So you have to find the time diagram of the output. So here input is given, that this I just write in the another pen, that this is T3 and T5. So this is 1, and for B that T2. So this is in for T4 and this one. These are the input. So here this is the A01 and the B01. We have to draw the output from these two. So you just this one input and going to 4 0, this is 1, and this is output. So here it would be the 0, this would be the output. And I just say one thing, that for the time diagram, this one is 0 0 and the out 1. So 0, this is the 0 and this one is the 1. So here B would be our correct answers. Option B is correct. Go through our next problem, that the JEE Main 2024 recent questions. The output Y of the given logic gate is similar to the output of an what gate. So here this is circuit and you have to find the output, that the here would be the output A dot A bar, and here that OR gate, so B plus B bar. So here this is become A bar and this is become the B bar, and Y would become the A bar plus B bar whole bar, that is A double bar dot B double bar, that is A dot B, basically the Y equal to AND gate A dot B. So D would be a correct answer, A dot B. That the final operation I just write here, A double bar plus B double bar, that whole bar, not single bar, that A bar plus B bar whole bar. So Boolean simplification, that this would become this, basically the A plus B bar, this would become the A bar plus 2 dot this one, and the A dot B bar, that would be the A bar dot plus B bar. So AB means the AND gate. Next one, that NEET 2024, consider the following statement A and B and identify the correct answer. So A, for a solar cell, the IV characteristic line in the IV quadrant in the given graph. B, in a reverse bias PN diode, the current measured in microampere due to a majority charge carrier. So basically here is a diode graph, that IV characteristic, this one. This is the IV characteristics of diode, and the solar cell, this IV, fourth quadrant. So A would be correct. A is correct because for solar cell IV characteristics lies in the fourth quadrant, this one, and B is incorrect because in a reverse bias PN junction diode, current measured in microampere due to a majority carrier, this is wrong, because in a reverse bias PN junction, the element due to a minority charge carrier which has very small and hence measured in a microampere. This is not a majority charge carrier, this is for a minority charge carrier. So this is wrong, A would be a correct answers. So next one, that, so I think one's problem given in a twice times. So we just now cover here the problem discussion session of the chapters Solid and Semiconductor Devices, and I usually give you for your homework, for your better concept understanding and clarification, you just pause this video and take a screenshot quickly. So I think you just would take a screenshot of this homework, and today finally we just cover the 10 important problem in these chapters Semiconductor Device and the Solid. So one question is missing out, so we just cover here the 9 questions. So I think after solving this question you go through the all over the problems coming in this chapter. So last but not the least, the contact section, solve this homework. If anyone need the study material of my YouTube lecture, just made without no hesitation, catsoninjas195@gmail.com. So last, thank you very much, stay happy and well, goodbye.